All right, so today we're going to go over the laws of logs, and this is for manipulating logarithms. These are probably going to be a review. You did these kind of extensively last year, so that's fine. All right, so first one here, product law. So multiplication inside of a log becomes addition in separate logs. And so, yeah, that's that. I always do like to remind people that these kind of always work both ways, so we could be moving from the left to the right or the right to the left. Quotient law, dividing inside of a log turns into subtraction of separate logs. And then exponent law, if you have an exponent inside of a logarithm, it can move to the front and become a coefficient. And then change of base formula, if you have log base a of x, for example, you can turn those into any base you want and have the x up here and the a down here. Now this one in the middle here, this one's actually the most popular. The base in that is base 10. And that's because then we can use a calculator, because most calculators, their log button is base 10. However, you could use the ln, because obviously your calculator also has an ln button. So I actually like to use that one sometimes. It really doesn't make a difference. I don't know why I use it. It's just, to me, it's a little bit more natural. Ha ha ha. All right. So now we're going to start expanding here. And so we're going to use all of our rules and expand this into as many logarithms as possible. So for number 1, I see I have multiplication inside, so I'm just going to expand that into 2 logarithms. So I'm going to say log base 3 of 5 plus log base 3 of y, and that's it. Number 2 then, I'm going to write that as log base 2 of x minus log base 2 of 2. Now I'm actually not going to stop there on that one, because log base 2 of 2, I actually know what that is. That is 1. So it is log base 2 of x minus 1. And I know that's 1 because if you kind of rethink that as 2 to what power gives you 2, and it's obviously 1. So then keep in mind, because I did not use parentheses, this x is inside the log, but this minus 1 is not inside the log. It's off on its own. So I would always do that if there's anything that we could simplify. All right, next up I will do number 3. So for number 3 here, I have an exponent inside. I'm just going to move that to the front. So we go 3 times log base 5 of x, and that's it. And then lastly, for number 4, now this one here, first of all, it's ln. And so remember, actually, I'll do this in pink. Ln. Remember, ln is a log, so it still does have all these same rules. And so what rule are we going to apply? Well, it looks like we can't apply any of them, but there actually is an exponent there, because we need to think of it as ln of x to the 1/2 power. And so if we think of it like that, then it would just be 1/2 ln x, and move it out to the front. So always keep that in mind, that whenever we have square roots, that is a fractional exponent. All right, next up, we're going to kind of start getting to some more complex ones. And so number 5 here, I'm going to split this up. Now I have 3 pieces inside the log, which means I'm going to end up with 3 logs. The trick I always use on this that's all very helpful is just I always put a little plus up top and a minus on bottom. Anything that came from the numerator is going to go in a positive log. Anything that came from the denominator is going to go in a negative log. So this one's going to be log base 2 of x squared minus log base 2 of y minus log base 2 of z to the third. And then I'm going to move all the exponents to the front. So it's going to become 2 times log base 2 of x minus log base 2 of y minus log base, oops, that one needs a 3. 3 times log base 2 of z. You may be thinking that these should be adding right here because they're multiplying down there, but remember, both of those are really dividing the x squared up top, and so that's why this trick for just doing the pluses on top, the positive logs on top, and then negative logs on bottom is more helpful. All right, next up, number 6. So for number 6, let's see, we have here the square root again, so let's just remember that the square root is really the 1/2 power. And so I can move that 1/2 power to the front here and call it log base 5 of x minus 1 over x plus 1. So then, when I split this up then, when you use my trick of just everything from the numerator is going to go in a positive log, the denominator is going to go in a negative log. So I have this 1/2 out front. So when I split it up, I'm going to say 1/2 parentheses log base 5 of x minus 1. And I do need to use parentheses there again because that x minus 1 is inside of that log base 5. And then minus log base 5 of x plus 1. And again, I need to use parentheses for that. Okay, so I think this is a good way to answer this question. I would be fine if you left your answer like that. Remember that we don't have any rules for adding or subtracting inside a log, so I cannot expand that one right there. What I could do though is I could distribute this 1/2 in there. And so I could call this 1/2 log base 5 of x minus 1 minus 1/2 of log base 5 of x plus 1. I think that's also an acceptable answer. I would think that WebSign would actually take either one of those. I don't think that one is better than the other. And if you kind of think about it, this 1/2 did apply to both of these, top and bottom, because the square root is around everything. So I can either show that it applied to both by using the parentheses with it kind of factored out front, or with it distributed inside. All right, next up here, number 7 and 7 through 10 here, we're going to rewrite these inside of a single logarithm. So now we're going to kind of condense this, but before we condense it, we should always if we have any coefficients in front, we should always move those inside the log, like so. And now we're going to condense it all into one log. And since we're kind of going the opposite direction here, I just think of it that anything that came from a positive log is going to go up top. Anything that came from a negative log is going to go on bottom. So 5 times 3 squared up top, and then 2 on bottom. So that's good right there. I think if you wanted to call this log of, let's see, 5 times 9 would be 45 over 2. I wouldn't have any problem with that either. All right, next up, number 8. We'll do some more condensing here. No coefficients on this one, so I'll just condense this as log base 5 of x squared minus 1 over x minus 1. Now on this one, I would actually factor that numerator, so I would call it log base 5 of x plus 1 times x minus 1 over x minus 1. And the only reason I would do that is because then we can cancel. And so then I can call it just log base 5 of x plus 1 as a more simplified version. Number 9, there's a couple different ways we can look at it, and I'll actually show you both ways. Will I? No, I think that the best way to do this is just to distribute that 2 first. There is another way to do it, but I think this is a lot easier to kind of visualize. So we'll just multiply everything by 2. And then I'll move all my coefficients up to be exponents, and I'm just going to do that right here, so I don't have to write everything again. So that'll become x squared, that'll become the 4th power, and that'll become z to the 6th. And then I'll build it all into one log base 5. I'll do all the positives on top and the negatives on bottom, and so I'm going to have x squared on top. I'll have z to the 6th on bottom, and I will have z to the 6th is up top because it came from the positive log there, even though it was not kind of in order. And then y to the 4th is going to be on bottom because that came from the negative log. So this will be my final answer. A quick note there, the other way you could write this one is log base 5 of, you could write it as x times z to the 3rd over y squared and have that all be squared. That one is kind of if you think about the properties of logarithms here, that 2 would multiply the properties of exponents, excuse me. That 2 would multiply by everything, and that's kind of more descriptive of that 2 being outside here, applying to everything. So either way. Okay, next up here, let's do number 10. So for number 10, first of all, I would call this the 1/3 power of a, since we have that coefficient. And so I'm going to condense this all into one natural log. And so that would be a plus b times a minus b all over a to the 1/3 power. I think if you left it like that, I could not say that that's wrong. That seems like an acceptable way to write it to me. If you did want to, you can actually foo that numerator because they are conjugates. So if you wanted to call that a squared minus b squared, I like the way that looks, so I have no problem with that. So I think that's an acceptable answer. Remember then, we are not allowed to reduce these because of the subtraction in the middle, though. That's the big thing you got to remember. So just leave it like that. Or the only other way I would write it is that if you wanted to call this the cube root of a, I got no problems with that either. So there's a lot of different ways to write that final answer. They are all acceptable. All right, next up we're going to do these without a calculator. And so if you're looking at number 11 here, and just like this first piece, the way we would have done this before is say 2 to what power gives you 1/12, and then also 2 to what power gives you 7. But obviously that's kind of not possible to think of those powers, and so we're going to use the laws of logs to condense this first. So I'm going to say log base 2 of 1/12 divided by 7. Since they are subtracting, we would divide them. All right, so then since this is no calculator, I'm going to have to use long division there. And so here we go. This is third grade math. All right. So it's 16. Okay, so really we have log base 2 of 16. And so now we're going to say 2 to what power gives you 16? And that's going to be the 4th power, not the 8th power. It's not 2 times x. It's 2 to the power of x, so it's 4. All right, number 12 here, a couple of different ways you could look at this. How I would do it is I would say log base 5 of 125 to the 1/2 power, and I would do that so I can use my property of logs to say log base 5 of 125. And then another thing you can do is you can say 1/2 times log base 5 of 5 to the 3rd. Since that's what 125 is, 5 to the 3rd power. And then again, you can move that 3rd power to the front and multiply it by the 1/2. Now remember, 3 over 1 times 1/2 is actually 3 over 2 times log base 5 of 5. And then whenever you have it to where the base and the number inside are the same, it's always 1 because it's saying 5 to what power gives you 5. So obviously that's 1. And so this is now 3 over 2 times 1, which is obviously 3 over 2. All right, lastly, number 13 here. So again, these ones, we're going to condense them. So log of 20 times 5. So 20 times 5, of course, 100. Remember, this is base 10. And so when we switch it to exponential form, we're saying 10 to what power gives you 100. And so that's obviously 2. All right, last set here, we're going to use the change of base formula to evaluate with a calculator. So this one, 14, is really not possible without a calculator, because we're saying 5 to what power gives you 2. So I think that is going to be a fractional exponent. It's going to be an exponent less than 1, because it's going to be kind of like a square root, but even less than that. But we're going to use a change of base formula. And so remember, the change of base formula says that we can write this as log 2 over log 5. And I always kind of remember that whichever one's on top in this original is still on top here. So the 2 is above the 5, and the 2 is still above the 5. So now we have changed this to base 10. You can also use ln for this if you like I said at the beginning. So I really don't like the way that the iPhone calculator does logs. So I'd really recommend either that app that I recommended, or if you have your own scientific or graphing calculator, that's great. Or if you can just use Desmos, that's fine too. So I'm going to do it here, log 2 divided by log 5, and that comes out to 0.4307. I'd say 4 digits is fine. So then for number 15, we'll just do log 92 over log 6. Nice and easy in the calculator here. It's going to be 2.5237. All right, so if you've got enough practice here, I'd say you could probably, skip 16 and 17. But if you wanted to do them, we'll be using this technique a lot in the next section here. So log 532 over log 6, and that's going to come out to 3.5031. And then for the last one here, log of 12.5 divided by log 12. And that should be a little bit more than 1, and yeah, it is 1.0164.